in Mexico City all my elementary education and either up to high school. And then in high school I wanted to do chemistry, and this after I decided that I wanted to do that, and because I found it extremely interesting. But then my teacher, I was, for some reason, I was interested in the what were nuclear phenomena. And then my teacher told me that I had to go to physics if I want to become a nuclear physicist rather than a chemist. So then I decided I have to go to physics. And that was back in the 60s. So being a nuclear physicist was very prestigious at that time, apparently. So that's why. But I always got interested in chemistry. For a while I considered to really take courses in both schools, which is possible in Mexico to take at the same time physics and chemistry, like majors. But I found that was too much, so I gave up a little bit of the chemistry. And then I went for my my bachelor's degree and then my master's in Mexico. And then I go on doing the PhD in Mexico, but at that time I finished up taking courses in Mexico, but we did not have good people to really be thesis advisors, okay, to really get you into something novel. So I decided that I should go to England to get somebody to give me a thesis and work in my thesis. And then I went to England because I was advised by Dr. Nicolas Cabrera. Was, in my opinion, one of the greatest scientists in the Spanish-speaking community. At that time, he was a very famous man. He went to Mexico because his family came from Spain, and then during the Spanish War, many people went to Mexico. So I think his mother was living in Mexico, so he used to go to the university and get involved in teaching, even though he was very famous by the Frank Burton and Cabrera theory of crystal growth. And he told me that surfaces were the way to go. And he called some friends in England, and then I went to first to Cambridge and to Warwick to work in my PhD thesis, which I finally succeeded in, finishing some experiments that I took back to Mexico. And I really got involved in catalysis after 6 years of working in Mexico in electron microscopy. I went to Oxford for a sabbatical. And then I became interested in small particles because I was trying to study nucleation phenomena, not really catalysis. I was not involved in catalysis at all. I didn't know anything about catalysis. But then when I came back to Mexico with all these techniques I had developed to study small particles, my friends in the Petroleum Institute in Mexico, by chance they invited me to give a seminar. And then I realized there that in catalysis there were exactly the same problems that I was working at in the other area. So I really didn't know that small particles were so important to catalysis until I got in contact with the petroleum people. And then I got involved in catalysis that way, which I found was very, very fruitful to me, because I had the techniques, I had the problem. I was a solution looking for the problem, okay, and they were the problem, okay. So it was very nice, and then I guess that was really the key point, and that's what I then tried to tell my students, that they always have to connect with the right problem. That's the right thing to do. And over the years, I've been learning, going back to my old love of learning chemistry, which I always wanted to do because I have to, for the, even to understand the language of my colleagues in the catalysis area, I have to really learn more about catalysis. And that's the way, even though I think, I look at the problems like a physicist, because I guess I cannot change that. The interaction with chemistry is one of my, what I consider a success in my career, with the interdisciplinary approach and this thing.
Yeah. What is it that you look for in deciding on a research area?
What are the objectives? What I look for normally? Well, you know, I want to have fun when I do research. If I have to do, you know, research which is not fun, I don't like it really. So I always look for areas in which the problems are fun, you know, not necessarily extremely hot problems or very prestigious problems, but something that gives you, you know, interest in thinking and something that you really learn something about it. Not just I don't like routine things. So, but I also don't like you know, get into fashions very easily, because fashions are very dangerous, especially if you are involving young people working with you in fashions. That might destroy their whole careers, which is. In fact, I learned that working in my PhD thesis. I worked in something that was almost already explored, but I found new things, and you know, my philosophy is you always learn new things when you attack the problem correctly. So I never want to do, but I have to have fun. I mean that it has to be something new, something interesting, and you know, there are many people. I just discussed that with some of my colleagues last week. There are people who always picked up the problem, okay, the biggest problem, and they want to solve the biggest problem. And I don't know any good example of anybody who has succeeded in that, okay. Whereas if you try to solve fun problems, you end up probably having something very important for other people. That's more or less what I think is my philosophy. And also, the other philosophy in Mexico is that we have a lot of limitations. So we cannot tackle all the research we want. We have to also be adapted to the conditions we have there, like equipment and budget is always important. We cannot decide on an experiment without thinking on the budget first. And I think this has done a lot of good to Mexico, because at the end makes the people thinking more in the experiments. And we do not have these biggest physicists involved in huge projects that take a lot of money and a lot of time, and that because we don't just have enough money, but then the tendency is to work in problems in which you can have some instrumentation in your own laboratory, which is rather than big facilities or big things. And also I like to cooperate with people. I think it's always fun to cooperate with people in different aspects and then learn about other people in the same problem. That's what I found is very exciting, that to interchange of ideas in this point.
But yet you were able to get the state-of-the-art microscope equipment in Mexico. Was this a conscious effort, or?
That took me a lot of effort. Well, first because I was appointed the director of a very prestigious institute, and that helped me a lot, so that opened me many doors. And this particular project, I have to really go up to the top in Mexico to get it, okay? In fact, I spoke to the president of Mexico about it, this project. And you see, I took advantage of one of the things that was probably a little bit of a lie, if you wish, that the president of Mexico used to read the Time and the Newsweek, always. This is the president de la Madrid. And he read about the superconductors, okay? And he was very excited. He learned that somebody in my laboratory had developed this levitation effect, which is very, and he wanted to know more about it. And then when we discussed and showed him, we said that we could do a lot of research in that area with a microscope of high resolution, which was not really, as I said, was a little bit of a lie, because even though we wanted to do some superconductivity, we really were more involved in catalysis and small particles. So we got the microscope that way. It was a special budget that was given by the president. So we got the microscope, and then the Institute of Physics has